Okay, let me talk to you a little bit about the magic of water. We know it's H2O, two hydrogens with one oxygen, and you know the Bohr model. You're going to know what that looks like by now. And they're sharing electrons over here, sharing pairs of electrons. So that's a covalent bond. Both of those are. But it's going to turn out they don't share them equally. This is a polar covalent bond, which means uneven sharing of those pairs of electrons. The oxygen has more electrons, and so the electrons tend to stay closer to it. It draws more of those negative charges near there, and it's pulling the one that's around this hydrogen closer over there. The sharing is not equal. Oxygen gets more of those negatives. So as a result, we have a partial positive charge on the hydrogen side and a partial negative charge on the oxygen side of every one of those molecules. Then this little sign here that looks kind of like an S, that means partial. So partial negative here with the oxygen because it's got those electrons closer, hydrogen, partial positive. And so this positive is attracted to that negative. And we end up with this wonderful mat of this attraction, and that is what makes water so vital for life. And a little bit more of that, the partial negative and the partial positive. And so we end up with this whole mat, like I said, where they're all connected with hydrogen bonds. Well, hydrogen bonds are pretty awesome, but there's something they do that nothing else does as well. They can work like a post-it adhesive. It'll stick where you want it and then come off when you don't want it to be attached. Why would that be important? Think of DNA. If you remember DNA, it's this double helix, and so it's a ladder that's twisted and twirled around, right? A twisted ladder, and these would be the steps of the ladder. So we've got two strands of DNA hooked together, and they're hooked together in the middle by hydrogen bonds. Why in the world? DNA is so important. Why would we want to be able to detach that? Why? To replicate it. We have to unzip it and then find new bases and hook them up. When we replicate a cell, we replicate the DNA. So I'm going to talk about the properties of water that make it act so wonderful. And these are the list of the 6 that we're going to talk about. First, it's a solvent. It used to be called the universal solvent, but not everything dissolves in it. Hydrophilic. Hydro, water, philic, love. City of Philadelphia, the city of love. So philic is to love. And that is going to dissolve in water. Example, salt. Here's some salt in there. There's your chlorine ion, there's your sodium ion, and they dissociate completely in water. And that means they dissolve in it. You don't see the salt crystals anymore. Hydrophobic means hydrophere. So that's not going to dissolve in water. Oh, here's hydrophilic again. And then hydrophobic. No charge, like oil and water, doesn't mix. So it doesn't have a charge. It's not polar, so it won't react with that polarity in that water molecule. Cohesion and adhesion. Cohesive, it sticks to itself. Adhesive, it sticks to other polar molecules. And an example is why, when you water a plant, it draws the water up. It's because it's evaporating, transpiring in the leaves. And so it's just kind of like sucking on a straw. And that's an example of cohesion and adhesion. The water sticks to itself as it's pulled up, and it sticks to the tree. High surface tension. It ends up having this coat of on the outside, almost like a skin, where those water molecules are more attracted to each other than they are to the air. And so certain things that are light enough can walk on it. And if you're clever enough, you can skip a rock. If you choose a flat one that you can throw just right so it doesn't break that surface very much. High surface tension. We use it all the time. This part is awesome. I'm not going to show you. You can watch it and decide if you think it's true or not, because I'm going to attach this in the class. I love it. It's well done. Let me come back. I'm already at 4.5 minutes, and I'll pick this back up again in the next one.